Hello, in this lecture we'll find out the area of the green semicircle using two different methods. In the drawing we have two semicircles. This is the white semicircle and this is the green semicircle. You know that this is 97 AC, that is equals to 5 units in its length. This is 97 CB, that is equal to 1 unit in its length. Repeat again, our mission is to find out the area of this green semicircle. So in the first step, we join points B and P together by a straight line. At point P, the two semicircles are tangent to each other. So, in the next step, I'll copy the white semicircle in a new page with the angle that we created here, and we will analyze the white semicircle. Actually, this is the white semicircle that I copied from the original drawing. Actually, by joining points B and P together by a straight line, we created here peripheral angle APB. We know that AB is the diameter of this semicircle, so I write it down. AB is the diameter of the semicircle. The diameter of the white semicircle. And we have here, this is peripheral angle APB that is subtended on AB, that is the diameter of this semicircle. I'll repeat again, this is peripheral angle APB, this angle, and it is subtended on AB, that is the diameter of this semicircle. Now we can implement here rule 7. I'll repeat quickly on rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle, then it is equals to 90 degrees. So in the drawing we have a circle. We have this circle and we have peripheral angle ACB. This peripheral angle ACB is subtended on AB, that is the diameter of the circle, and therefore, according to this rule 7, peripheral angle ACB equals to 90 degrees in its size. Here, peripheral angle ACB equals to 90 degrees in its size because of the fact that it is subtended on AB, that is the diameter of this circle. Again, according to rule 7, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. So we can implement rule 7 in our drawing. In our drawing, we have peripheral angle APB that is subtended on AB, that is the diameter of this semicircle, and therefore, according to rule 7, peripheral angle APB equals to 90 degrees in its size. So I write it down. Peripheral angle APB is equals to 90 degrees in its size according to rule 7 because of the fact that it is subtended on the diameter of this semicircle. Okay, so this is a right angle. Angle APB is a right angle according to rule 7. In the next step, we will join points P and C together by a straight line, and then I'll copy the green semicircle in the new page with the angle that we created here, and we realize the green semicircle. So we join points P and C together by a straight line. In the next step, I'll copy this green semicircle with the peripheral angle that we created here in a new page. And we'll analyze this green semicircle. Our mission is to find out the area of this green semicircle. Actually, this is the green semicircle that I copied from the original drawing. By joining points P and C together by a straight line, we created here peripheral angle ACP. This is peripheral angle ACP, and AP is the diameter of the green semicircle. So I'll write it down. AP is the diameter of the green semicircle. And we have, this is peripheral angle ACP, and peripheral angle ACP, peripheral angle ACP is subtended on AP, that is the diameter of this semicircle, therefore it is equal to 90 degrees in its size according to rule 7. So it is equal to 90 degrees in its size according to the same rule, rule 7. Because of the fact that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. So this angle PCA or ACP equals to 90 degrees in its size. According to rule 7. Actually, if we look in the original drawing, this angle PAC or PAB, it is a common angle that belongs to both right angles. It belongs to the right angle PCA, and it belongs to the right triangle APB. Okay, so this is a common angle. So we define the common angle. This angle is alpha. And therefore, this is the same angle. This is equal, of course, to alpha. So in the right green triangle ACP, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing third angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle APB, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. So in the next step, I will copy the two right triangles, this right triangle APB and this right green triangle ACP in a new page, and we will prove that those two right triangles are similar to each other according to angle similarity rule. So I'll copy those two right triangles in a new page. Side AB, this is side AB. You can see that side AB in total, side AB equals to 5 plus 1, that is 6. Again, side AB equals to 5 plus 1, that is 6. So here you can write down that side AB equals to 6 units in its length. Likewise, in this right green triangle APC, side AC equals to 5 units in its length according to what is given us the question. So actually, those are the two right triangles that I copied from the original drawing. So in the next step, we will prove that those two right triangles are similar to each other according to angle similarity rule. So we will prove, actually this is the right green triangle, this is the right green triangle APC. This is So we prove that the green right triangle APC is similar to the white right triangle APB. So I'll write it down. We prove that the green right triangle APC is similar to this white triangle APB. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually, this is angle PCA in the green triangle, and it is equal to this angle, that is actually angle APB in the white triangle. Repeat again. Angle PCA in the green triangle equals to angle APB in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. in addition, this is angle alpha, that is a common angle, it belongs to both triangles, so we can write down that angle alpha equals to itself is a common angle that belongs to both triangles. So we just call to angle alpha two different names. So angle alpha, if we relate to this green triangle, angle alpha can be defined as angle PAC. And angle alpha equals to itself. So if we define angle alpha as it belongs to the white triangle, it will be defined as angle PAB. Repeat again. This equation means that angle alpha equals to itself as a common angle that belongs to both triangles. We just call to angle alpha two different names. Okay, and finally, those two angles, they are both equal to 90 degrees minus alpha, therefore they are equal to each other. So actually this is angle APC. In the right main triangle APC, and it is equals to this angle, that is actually angle ABP. In the white triangle APB. Repeat again. Angle APC in the green triangle equals to angle ABP in the white triangle. They are both equal to 90 degrees. They are both equal to 90 degrees minus alpha, therefore they are equal to each other. So actually found out that all the three angles in the green right triangle PCA are correspondingly equal to all the three angles in the white triangle BPA. Therefore those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually found out that the right green triangle PCA is similar, this is the sign of similar, to the right white triangle APB, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationships exists between their sides. But before that, we know that AC equals to 5 units in its length, according to what is given as the question. AC equals to 5 units. So we derive that the following relationship exists between those two similar triangles. That AC in the green triangle, side AC in the green triangle, over side AP in the white triangle equals to side AP in the green triangle over side AB in the white triangle. So I repeat again, I actually found out that AC over AP equals to AP over AB. AC equals to 6 units, so it's left. So we substitute AC equals to 5 units in its length. So we substitute AC by 5. So it is 5 over AP. AP is the missing side, so we leave it as it is. And it is equals to AP, again AP is the missing side, over AB. AB equals to 6 units in step, so we substitute AB by 6. So I actually found out that 5 over AP equals to AP over 6. Here we cross multiply this equation and we get that 5 times 6 is 30. So 30 equals to AP squared. 30 equals to AP squared. Here we take a root out of this equation. And finally we get that AP equals to the square root of 30. So AP. So we actually found out that AP that is the diameter of the green semicircle, equals to 30 square root of 30 units in its length. And we have already found out that AP is the diameter of the green semicircle. If AP is the diameter, it means that AP over 2 must be the radius. So the radius of the green semicircle equals to AP over 2. AP over 2 is the radius. So we define the radius as R. So the radius of this semicircle equals to AP over 2. AP square root of 30. So actually found out that the radius of this green semicircle equals to the square root of 30 over 2 units. And we know that the area of a semicircle equals to the area of the circle over 2. And the area of the circle equals to pi r square. So pi r square over 2 is the area of the green semicircle. And again, the area of the green semicircle equals to pi r square over 2. So it is pi, and r is equal to 30 over 2. Therefore, r squared is equal to 30 over 2 squared divided by 2. So the area of the green semicircle will be equal in total to, we have pi square root of 30 square is 30, and 2 square is 4 divided by 2. So if we found out that the area of the green semicircle equals to 30 pi over 2 times 4. 30 over 2 is 15. So in total this expression will be equal to 15 pi over 4 square units. Or it is 3.75 pi square units. And in terms of numbers, it is equal to 11.78 square units. Okay, again, I should have found out finally the answer to the question is that the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, it is equal to 11.78 square units. So we finished with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. In the second method, we join points P and B together by a straight line. So I'll copy the white semicircle in a new page, and we will implement on the white semicircle rule number 7. We actually have already done it in the first method, but I will repeat it anyway, on the process anyway. So actually, this is the white semicircle that I copied from the original drawing. So, by joining points P and B together by a straight line, we created peripheral angle APB. Created peripheral angle APB. I already explained to you that AB is the diameter of the semicircle, so I write it down. AB is the diameter of the semicircle, and we have here, this is peripheral angle APB. This is peripheral angle APB that is subtended on AB, that is the diameter of the semicircle. And according to rule 7, any peripheral angle that is subtended on the diameter of the circle or semicircle must be equal to 90 degrees in its size. Okay, therefore this angle equals to 90 degrees in its size according to rule 7. Okay, so here BP creates 90 degrees with PA. Again, BP creates 90 degrees with PA. BP creates 90 degrees with PA. So we define the center of this green semicircle. This point is point O. So the center, and I will copy point O from this the original drawing to this drawing. So this is point O that I copied from the original drawing. Because of the fact that point O is the center of the green semicircle, and point P is a point on the semicircle itself, it means that PO is the radius of this semicircle. So we define the radius of this green semicircle as R, therefore PO equals to R. This is the radius of the green semicircle. So here also we can write down that PO is the radius of the green semicircle, therefore it is equals to R according to our definition. So actually here BP creates 90 degrees if the radius PO. Again, BP creates 90 degrees if the radius PO. So, and according to rule 1, repeat quickly on rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. We have here the radius OM is perpendicular to to tangent AB because of the fact that the radius OM is known to point M. Therefore, tangent AB is perpendicular to the radius MO. That is to say, any straight line that creates 90 degrees with the radius, it must be a tangent. Again, any straight line that creates 90 degrees with the radius must be a tangent. Why? Because here you can see that AB creates 90 degrees with the radius OM, therefore AB is defined as a tangent, and therefore here we have BP creates 90 degrees with the radius PO, therefore it must be a tangent. Again, because of the fact that BP creates 90 degrees with the radius PO, it must be a tangent, according to rule 1. Therefore BP is a tangent, is tangent to this green semicircle. Again, BP is tangent to the green semicircle, and the point of tendency is at point P. Why? Because it creates 90 degrees. Creates 90 degrees with the radius PO, and any straight line that creates 90 degrees with the radius PO, it is defined as a tangent. Okay, so therefore here BP is a tangent to the green semicircle at point P. Okay, BP is the tangent to the green semicircle at point P. So here we can implement a new rule. We have here tangent PB, that is tangent to the green semicircle at point P. So I'll copy tangent BP with the green semicircle in a new page, and we will implement the new rule in the drawing. So actually, from the external point B, we have tangent BP to this the green. It is originally the green semicircle. So this is the green semicircle actually. So from the external point B, we have tangent BP that is tangent to this green semicircle at point P. Point P is the point of tendency of tangent BP with this green semicircle. And we have chord AC, and from point B, we have extended point B until it creates here chord CA. So according to the new rule in this drawing, the following equation will be true: that PB square, that is the score of the tangent, PB square or BP square must be equal to BC, that is 1, BC times BA. Again, according to the new rule, in this drawing, the following equation is true, that PB squared, that is the score of tangent VP, equals to BC times BA. Okay? BC is 1 and AC is 5. So in total, AB equals to 5 plus 1, that is 6. So we substitute AB by 6, and we substitute BC by 1, and get that BP squared equals to 1 plus 6, that is 6. So BP squared equals to 6. We take out of this equation, and finally we get that BP equals to the square root of 6. BP equals to the square root of 6 units, it's done. In the next step, I'll copy the right triangle APB. Here, BP equals to the square root of 6 units. So I'll copy the right triangle APB in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle APB. So actually, this is the right triangle APB that is according to the original drawing, and according to the Pythagoras theorem, here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is AB, therefore the square of the hypotenuse is AB squared. And AB squared must be equal to PB squared plus AP squared. So I'll write it down. According to the Pythagoras theorem, in this right triangle APB, AB squared, that is the square of the hypotenuse, must be equal to AP squared minus PB squared. AP squared plus PB squared. Again, according to the Pythagoras theorem, in this right triangle APB, AB squared equals to AP squared plus PB squared. So here we subtract PB squared from this equation, and we get that AP squared, that is the missing side, equals to AB squared minus PB squared. AP is the missing side, so we repeat as it is. So AP squared equals to AB squared. AB is 6, therefore AB squared is 6 squared, that is 36, plus minus PB squared. Minus PB squared. PB is square root of 6, therefore PB squared is square root of 6 squared, that is 6. So in total, I actually found out that AP squared equals to 36 minus 6. 36 minus 6 is 30. So I actually found out that AP squared equals to 30. Here we take a root out of this equation, and finally we get that AP equals to the square root of 30 units in its length. So this is side AP, that is the diameter of this semicircle. So I've actually found out that the length of the diameter of this green semicircle is 30 units in its length. Therefore, the diameter over 2 is the radius. So R equals to the diameter AP over 2. AP is equal to 30, therefore therefore square root of 30 over 2 is the radius. So actually found out that the radius of the green semicircle equals to the square root of 30 over 2 units. And we know that the area of this green semicircle equals to the area of the circle over 2. So the area of the green semicircle in total will be equal to pi r squared, that is the area of the circle, over 2. So it is pi, and r is square root of 30 over 2. Therefore r squared is square root of 30 over 2 squared divided by 2. So the area of the green shape equals to pi, and square root of 30 squared is 30 over 2 squared, that is 4, divided by 2. So here we have pi times 30 over 4 times 2. Here 2 will transmit 2 to the denominator here, and in total the area of the green semicircle equals to 30 pi over 2 times 4. 30 over 2 is 15, so in total the value of this expression equals to 15 pi over 4 square units. That is actually 3.75 pi square units, or in terms of numbers, it is equals to 11.78 square units. So, according to the second method, we actually found out that the area of this semicircle equals to either 3.75 pi square units, or in terms of numbers, it is equals to 11.78 square units. So, in the next step, I will summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the area of this green semicircle. So, in the drawing, we have two semicircles. We know that this is line segment AC, that is equals to 5 units in its length. This is line segment CB, that is equals to 1 unit in its length. And again, our mission is to find out the area of this green semicircle. So, in the first step, we join points P and B together by a straight line, and then I copied the white semicircle in a new page, and we analyze this white semicircle. This is the white semicircle that I copied from the original drawing. Actually, by joining points P and B together by a straight line, we created here peripheral angle APB. This is peripheral angle APB. And you know that in this semicircle, AB is the diameter of this semicircle. Again, AB is the diameter of this semicircle. And we have here peripheral angle APB that is subtended on AB, that is the diameter of this semicircle. And therefore, you can implement rule 7. According to rule 7, if a peripheral angle is subtended on the diameter of the circle, this equals to 90 degrees. So here we have peripheral angle ACB, and is subtended on AB, that is the diameter of this circle. Therefore, this peripheral angle ACB equals to 90 degrees according to this rule, rule 7. We can actually implement rule 7 in our drawing. Why? Because in our drawing, we have peripheral angle APB that is subtended on AB, that is the diameter of the circle, and therefore the diameter of the semicircle. Therefore, peripheral angle APB must be equal to 90 degrees in its size. So this angle APB equals to 90 degrees in its size. In the next step, we join points P and C together by straight line, and then I copied the green semicircle in the new page, and we analyze the green semicircle after we join points P and C together by straight line. So this is the green semicircle that I copied from the original drawing. Actually, after we join points P and C together by straight line, we created here peripheral angle ACP. This is peripheral angle ACP, and again here AP is the diameter of this green semicircle, and we have peripheral angle ACP that is subtended on AP, that is the diameter of this semicircle, and we know that according to rule 7, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral angle ACP equals to 90 degrees in its size. Okay? So, we know that this angle equals to 90 degrees in its size according to rule 7. We define this angle as alpha, and therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Okay? Actually, angle alpha is a common angle that belongs to both triangles. Here, this is angle alpha. Angle alpha belongs to the green triangle APC, and angle alpha belongs also to triangle APB. Therefore, it is a common angle that belongs to both triangles. Okay, so here angle alpha belongs also to this triangle APB, and therefore in the right triangle APB, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Then I copied the two right triangles in a new page, and we actually proved that the two right triangles are similar to each other according to angle similarity rule. So actually, those are the two right triangles that I copied from the original drawing, and I actually proved that those two right triangles are similar to each other according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle alpha, that is a common angle that belongs to both triangles, so we can find out that angle alpha equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So I actually proved that all the three angles of the right green triangle PCA are correspondingly equal to all the three angles of the right triangle APB. Therefore, those two right triangles are similar to each other according to angle similarity rule. Okay, again, the green triangle PCA is similar to the white triangle APB according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AC in the green triangle or side AP in the white triangle equals to side AP in the green triangle over side AB in the white triangle. I'll repeat again. We derive that AC over AP equals to AP over AB. AC equals to 5. So we substitute AC by 5 over AP. AP is the missing side, so we leave it as it is. AP over AB. AB is 6, therefore we substitute AB by 6. And finally found out actually that 5 over AP equals to AP over 6. Here of course multiply this equation and finally found out that 5 times 6, that is 30, equals to AP squared. Here we took a root out of this equation and finally found out that AP equals to the square root of 30 units in its length. So actually, this is AP. AP it is actually the diameter of this semicircle and it is equals to the square root of 30 units in its length. If the diameter AP equals to square root of 30, it means that the radius must be equal to half of it. The radius is AP over 2. Okay, so the radius of this green semicircle equals to the diameter AP over 2. AP is square root of 30, therefore AP over 2 is square root of 30 over 2. So we actually found out that the radius of this green semicircle equals to the square root of 30 over 2. And we know that the area of any circle is pi r squared over 2, and therefore the area of this green semicircle must be equal to pi r squared over 2. Again, the area of any circle is pi r squared, and therefore the area of this green semicircle must be equal to pi r squared over 2. Okay, so the area of the green semicircle must be equal to pi r squared over 2. So it is pi, and r is square root of 30 over 2, therefore r squared is square root of 30 over 2 squared divided by 2. So here we open the brackets and we got here that it is pi and square root of 30 square is 30 and over 2 square is 4. So in conclusion, we found out that the area of this green semicircle equals in total to 30 pi over 2 times 4. 30 over 2 is 15, so in total this expression equals to 15 pi over 4 square units. 13 over 4 is 3.75, therefore in total this expression equals to 3.75 pi square units. So I actually found out that according to the first method, the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, it is equals to 11.78 square units. So we finished with the first method. In the next step, I presented to you how to find out the area of this green semicircle according to the second method. In the second method, we joined points P and B together by a straight line, and then I copied the white semicircle in a new page and we implemented rule 7 on the white semicircle. So this is the white semicircle, and after we joined points P and B together by a straight line, we created here peripheral angle APB. We already found out that AB is the diameter of this semicircle, and peripheral angle APB is subtended on AB, that is the diameter of the semicircle, and according to rule 7, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral angle APB equals to 90 degrees in its size. Actually, BP creates 90 degrees with PA. Okay, so here BP creates 90 degrees with PA. PA is the diameter of this green semicircle. If PA is the diameter, here PO is the radius. So PO is the radius. So actually, BP creates 90 degrees if the radius PO of this green semicircle. Therefore, we can implement here rule 1. Repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So, if we have a straight line that creates 90 degrees, if the radius OM, it is defined as a tangent. Here, we have the radius OM that is equals to R, and we have the straight line AB that creates 90 degrees with the radius OM at point M. Again, the straight line AB creates 90 degrees with the radius OM, therefore AB is defined as a tangent. Therefore, according to rule 1, we have here the straight line BP creates 90 degrees with the radius PO at point P, and therefore, according to rule 1, BP must be a tangent to this semicircle at point P. According to rule 1, a tangent BP creates 90 degrees at the point of tendency with the radius PO. Therefore, in conclusion, we can say that BP is definitely the radius the tangent to the green semicircle. BP is tangent to the green semicircle at point P. Okay. Here BP is tangent to the green semicircle at point P. This is again. Here line segment BP is tangent to the green semicircle at point P. Therefore, line segment BP is defined as a tangent. Actually, line segment tangent BP is tangent to the radius PO of this green semicircle at point P. And here we can implement a new rule, because we have from the external point B, we have tangent BP to this semicircle, and from the same external point B, we extended the external point B by a straight line until it creates chord CA or AC. So in this drawing, the following equation will be true, that BP square or BP square equals to BC times BA. Again, according to the new rule, BP square equals to BC times BA. So whenever you have an external point to the circle, to the semicircle, and from the external point you create a tangent, and from the same external point, point B, you created chord CA, then the following equation will be true, that BP squared, that is the square of the tangent, equals to BC times BA. Again, BP squared equals to BC times BA. So, here, BP squared equals to BC. BC is 1, so we substitute BC by 1 times BA. BA equals to, in total, to 5 plus 1, that is 6. So we substitute BA by 6. So in conclusion, we found out that BP squared, that is the square of the tangent, BP, equals to 6. We took a root out of this equation, and finally found out that BP, the missing tangent BP, equals to the square root of 6 units in its length. In the next step, so here, BP equals to the square root of 6 units in its length, and AB equals to 6. AP is the missing side. So I copied the right triangle APB in a new page, and we implemented the Pythagoras theorem on this right triangle APB. We have two sides, so we can easily find out the missing side AP. We know that the hypotenuse AB equals to 6 units in its length, side PB equals to the square root of 6 units in its length, and AP is the only missing side, so we'll find out the missing side AP by implementing the Pythagoras theorem on this right triangle, triangle APB. So this is the right triangle APB that I covered from the original drawing. Again, AB, the hypotenuse AB is 6, PB is square root of 6, and AP is the only missing side. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is AB, therefore the square of the hypotenuse A is AB squared, and AB squared must be equal to AP squared plus PB squared. Here we subtracted PB squared from this equation, and finally found out that AP squared, that is the square of the missing side AP, equals to AB squared minus BP squared. And AP squared equals to AB squared minus PB squared. So AP squared equals to AB squared. AB is 6, therefore AB squared is 6 squared, that is 36, minus PB squared. PB is square root of 6, therefore PB squared is square root of 6 squared, that is 6. So in total, actually found out that AP squared equals to 36 minus 6, that is 30. So AP squared equals to 30. Again, AP squared equals to 30. We took out of this equation and finally found out that AP, the missing side AP, equals to the square root of 30 units in its length. So actually, AP, found out that AP equals to the square root of 30 units in its length. AP is the diameter of this green semicircle, and this is equals to the square root of 30 units in its length. If the diameter AP is square root of 30, it means the radius must be equal to half of it. So the radius must be equal to the square root of 30 over 2. Repeat again. The diameter AP is equal to 30, therefore the radius must be equal to half of it, that is AP over 2. AP is equal to 30, therefore AP over 2 is equal to 30 over 2. So actually found out that the radius of this green semicircle R equals to the square root of 30 over 2. And the area of this green semicircle must be equal to the area of the circle, that is pi r square over 2. Again, the area of the green semicircle equals to pi r square over 2. The radius of the semicircle R equals to the square root of 30 over 2. Therefore, in total, the area of the green semicircle is pi r square over 2. So it is pi and r is square root of 30 over 2. Therefore, r square is square root of 30 over 2 squared divided by 2. So here we have, we open the brackets here, pi times square root of 30 squared is 30, and in the denominator we have 2, so 2 squared is 4, which is 4. So in total this expression equals to 30 pi over 4 divided by 2. So here 2 will be moved to the denominator here, and we get in total that this green shape equals to 30 pi over 2 times 4. 30 over 2 is 15, so in total the value of this expression is 15 pi over 4 square units. 15 over 4 is 3.75. So in total we shall found out that the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, the area of this semicircle equals to 11.78 square units. Okay, thank you very much.